it's a rainy day, so those of us who are joining via Zoom, thanks so much. We are here to have a conversation today about computational social science, and particularly what big models and big data bring to the table. So this discussion is part of a series organized through an APSA special projects grant to some of us at the Johns Hopkins University called Learning How to Play with the Machines. The idea is that we have been trying to increase the collaboration and the communication between between the computational side and the social side of computational social science. That being said, this is the fifth in the series after four that we held last year at the APSA annual meeting, Johns Hopkins University, the Dora conference, and the University of Michigan. So thank you to the four of you for joining us. I hope that we can start with a round of introductions, and then we will move through some questions to guide a discussion. The idea is that we would like this to be fairly free-form. Feel free to jump in on top of each other. If you have a particularly hot take, keep it ready. With that, let's get started. Is it okay if we start at this end of the table?
Sure. So hey everybody, my name's Austin Van Loon. I'm a PhD student at Stanford University. Get your booze out of the way. But I'm in the sociology department there, and I do a lot of computational social science. Kind of found my way into computational methods pretty early on in grad school, and love playing with language.
So, hi, I'm Lucy. I'm a PhD student at UC Berkeley, and I have a master's in computer science, and now I'm currently at the School of Information. I mostly work on NLP for social science and also AI fairness, and some applications that I've worked on, domain applications I've worked on are things like education.
Hi everyone, my name is Kristina Gligorić. I'm now a postdoc at Stanford. Before that, I got my PhD in computer science at the EPFL in Switzerland. I'm broadly interested in computational social science, in particular how we can use these large-scale digital data sets to understand, measure, and change human behaviors. And recently, I'm especially interested in online behaviors and the issues that online platforms face.
Hi everyone, my name is Ethayarajh. I am a PhD student with Dan Jurafsky in the computer science department at Stanford, and I primarily work on evaluating and debugging language systems, not just evaluating the model itself, but the data that goes into it, the metrics we use to evaluate models, and evaluating with respect to real-world utility.
Right. Thank you, everyone. Thank you also to the Berkeley NLP Seminar Series for hosting us today, and especially to Helena for making all of this happen. With that, why don't we get started? So the topic today, what do big data and big models bring to the table? So in your experiences, what do they bring to the table? Things like BERT, XLMR, T5, GPT, recently even maybe ChatGPT have found its way into at least the discussion, if not the research itself. So what do these bring to computational social science compared to prior tools or approaches?
Okay, sure, yeah, I can start. So I think it's important to distinguish between kind of, in this bundle of models and that question, there's kind of like two groups that are important to distinguish. One is, analyst facing, I would call them. So here, like with BERT, for instance, like, an end user might not be necessarily interested in this vector of numbers that BERT can give you, but it's valuable potentially for us social scientists, right? And for those of us doing computational social science. And those are really helpful for us because, well, specifically the ones that are trained on these large corpora ahead of time, because, language is this really interesting gateway into, the psychological and sociological processes that are happening out there in the world. But it can take a lot of data for machines to be able to analyze that in a useful way. And so obviously, like BERT is trained on a large corpora, so it can kind of do that ahead of time, which is nice, though it has drawbacks. Then there's also what you might call the, user kind of focused ones like ChatGPT, where an end user, like, celebrities can just go on there and find it really impressive and then talk about it. So now, and these are still, the applications are very different. I see kind of three different ways that I expect them to be kind of used widely in research. Besides, writing papers, etc. But the three kind of ways I imagine them being used in research, for better or for worse, one, you could imagine, a lot of times in social science research, you have to do kind of interpretive kind of work, right? So for instance, I get a set of documents, I need to hand label some of them, and that can be really time intensive and really expensive. And so I imagine a lot of people are going to start moving to using, for instance, ChatGPT or GPT-3, similar large language models, to just do the coding for them, right? And it's kind of all baked into this large language model. It can just do that with a very kind of normal command you might give to a human coder. Second way that I can imagine it being used is as a research subject, which it sounds like some people on this panel, for instance, doing. I think that's really important work. It's, for instance, systematically giving prompts to these language models and seeing how they react. I guess you could also do that with code. But I think that's going to be a really popular area of research, especially in computer science. And then the third is as kind of I think where social scientists are really excited as a way to kind of generate stimuli for instance, experiments. And so here, you can imagine, it almost gets science fiction or science horror maybe, if you start to think about it too much. You can imagine, for instance, Twitter bots that are powered by these large language models and interact with people in kind of a field experimental setting, interacting with other users, and you could be randomly assigning, for instance, the prompts that these language models are acting off of, so you could have relatively uncivil language from a Twitter bot or relatively civil language. I've heard people talk about wanting to do like different kinds of therapy modalities through like apps that people might download onto their phone. And the nice thing, of course, about that is we have some treatment difference we're interested in. So for instance, civil versus uncivil language, that's very difficult to operationalize, especially on the fly when interacting with a whole bunch of potential participants. But of course, these language models kind of simplify that for researchers. And again, there are huge drawbacks to all of these, and I'm not necessarily condoning any of these projects' ideas that I'm talking about. But I think those are kind of the three pathways we're going to see things like ChatGPT be used in social science research.
Thank you. But before anyone else jumps in on that, you used the word coding in a way that may be unfamiliar to someone in NLP. Do you mind just clarifying the distinction?
Yeah, so for instance, like if I were doing a project on what are the consequences of being exposed to like uncivil language in policy discourse or something, then I need to, and I have some like observational data set. I see people are exposed to uncivil or civil language on say some kind of chat forum or something. I need to know what language is civil versus uncivil. And so kind of the classic approach in the social sciences was you would have research assistants, for instance, or maybe PIs on the project or grad students go through some of these, go through these different messages and hand code them, decide manually whether they are civil or uncivil. And then of course, with unsupervised machine learning, then the idea was you could take these, hand codes and then propagate them to a larger set of data. But now with ChatGPT, I think people have become excited about the idea of just telling ChatGPT, hey, for each of these code, whether it's civil or uncivil, and then it's kind of zero shot, being able to, enact some kind of coding at least on all these messages you might have.
Right, thank you.
So what big models bring to the table? I think, so a lot of it is just better accuracy, better F1 scores, better performance on a bunch of different tasks. Because there's this pattern in a lot of work where you propose a task where you want to measure some sort of social or behavioral phenomenon, and then you create a model that can do it, and then you apply it to a larger data set and try to get some social scientific finding from it. But in the past, what might have happened is that you get like a certain F1 score and you get a certain amount of accuracy, and you kind of just have to like put up with it. You might be like 20% of the things I'm classifying are going to be incorrect, but I'm still going to just like apply it and try to see what I get. While now that accuracy and that performance is going to be a lot better, and so you can be more confident about the robustness of your findings. So I think that's what they're kind of bringing to the table is like you don't have to, because there were some tasks in my work where we would look at an existing model that could perform a certain amount of an F1 score, and we looked at it and we were like, that F score is not good enough for us to actually apply it in this high stake domain. But now maybe things are a little bit different.
Yeah, what I wanted to add about what big data and big models add to the table is also to focus on big data, because they cannot really be separated from the large behavioral data sets that they were trained on. And I think here it's easy to a bit take it for granted, all the benefits that such data sets have for social sciences, which is really, really exciting because if we think about it, before behavioral data was very scarce, it was very costly, logistically complicated to even collect behavioral data sets, but now with digitalization, behavioral data is abundant, and this even leads to democratization in a sense that if before it was very complicated to gather a lot of survey data or to collect your corpus, now any grad student can potentially collect a set of tweets, very recently, and analyze those. So it's really a complete transition, and I think that's very exciting. So just the ability to have this kind of large, passively sensed digital data sets that we can analyze, and then of course the big models, they are suitable methodologies to deal with this data because old ways of doing science, where we would test some hypotheses based on some theories and compare things, this just doesn't hold. So what does that mean if we work with a huge corpus or a huge set of behavioral traces? So that's something else that I wanted to emphasize, that we shouldn't forget the big data when we talk about the big models.
So I think one aspect of large models that gets the most attention is their ability to generate, but I think in practice what's really useful is their ability to extract like useful features in like a condensed representation. And I think, for example, you can use that for a lot of predictive problems and also interpretive problems. And prior to big models, at least in NLP, like a common way of going about that would be using like n-gram features, which is much more tedious and not as easy to use prediction task. And I think another interesting something that is allowed by large models is the ability to ask questions of a much larger scale. So for example, one project I worked on sort of before the large language model era was at the law school at the University of Toronto, where we were thinking about like how do we make sure that like the Supreme Court in India is following precedent, because the way the court is structured is like very different from the US Supreme Court, and you have smaller panels of judges and they process a lot more cases, like orders of magnitude more cases, because of the way the legal system is structured. And so it's not really feasible for an individual legal scholar or even a team of legal scholars to like go through cases one by one to see if citation is being properly followed. And it's a hard question to answer, but using things like word features, citation graphs, all makes it easier. And this kind of large-scale question, I think, or answering such large-scale questions has been enabled by this generation of models.
May I add something? In relation to what Kawin was saying, last year at MAPSA in Chicago, there was a group that is working in collaboration with the Ministry of Justice in Norway, that to avoid backlog or overwork to particular type of cases, they're using a lot of these features to streamline and see how things can be solved faster, or whether or not as much time from a lawyer is needed as in normal system. Yeah. So, and that is supposed to actually be scaled up to potentially the entire portfolio of cases that the courts may be seeing. So it's going somewhere.
That's very interesting, yeah. I think different countries have like very different attitudes towards adopting technology into their processes, and oftentimes it's much easier to use it as like an analytical tool, as we did, instead of like using it to speed up the process itself, which I think takes a very forward-looking government. So I'm not surprised it's like Norway or doing this.
Well, thank you, everyone. That's a pretty good notion of like what the benefits could potentially be of both the data and the models, and some useful framing. What about the downsides though? Like, what do big data or big models leave behind? Obscure? What do they miss? Are there blind spots?
Let's start at this end, just so that like there's some fairness to like.
Sure.
Because we steal all the good ideas and then you're like, oh no, what was I saying, right?
Yeah, so I think these models have a lot of blind spots. For one, especially the latest generation of large language models, they're trained on corpora from the web, which is like disproportionately in English compared to all of the content that's out there in the world. it also tends to come from certain subsets of the population that are writing this content or whose opinions and views are overrepresented, and so models learn these attitudes as well, and they can sort of act as priors for the judgments models ultimately make. So I think as we move forward, and as all of these models are used increasingly in research and in production out in the real world, we need to think about the data that goes into these models, whose opinions are reflecting, and how we might correct that, especially as we deploy them to different legal systems and different cultures all around the world.
Yes, I totally agree that the limitations and the drawbacks of big models come also from the data that is fed into them. So I could elaborate on some specific harms that can perpetuate in that way and be further amplified algorithmically. So the non-representativeness of the data for sure is a big problem, and then we also have models that don't work well for all the languages. Another big problem with training models on data that is collected on the web is the fact that the data on the web is algorithmically confounded. So the data that goes in models is shaped by, for example, the design of online platforms. So that's something that I could find in my research, that design choices that Twitter does, for example, even something as simple as how long is a character limit shapes the nature of tweets that people post. So, and that's something as simple as character limit. And then when we think about recommender systems, just the design of the web, there are huge algorithmic confounding that happens. Then another issue that I think a lot about, and that I'm worried about both for data and for models, is the level of access. So who has access to what data, and then who has access to what models, and then if we rely on these very powerful new methodologies, what does that mean for access to technologies that different researchers have in different countries, and does it further exacerbate those, or does it help? So that's something that I've been thinking about recently.
So I think there's the data representativeness that people have mentioned, but also things like domain transfer, and even just let's say you did train on the domain that you want to study, but you're studying such a small domain that you want to be able to separate out things that BERT might have learned that you don't care about. Like, let's say you want to study a social group in a small data set and how that social group is represented, but BERT or these big models will come in with all these preconceived notions of what they think the social group is represented as, and you want to separate that. That's a little bit harder. Yeah, so I think it's just what if you have a small task? What if you have a small domain? What do you do with the big model?
Yeah, I'm totally feeling you guys have all said the good ideas now. But I guess I just maybe to add one more thing to the representativeness of the underlying data that the model's trained on. I think a lot of people, folks in social science who I very much respect their opinions on these, but they'll say, well, you can fine-tune BERT, for instance, on your small corpus. I'm very skeptical that gets rid of the problem, right? Because you could imagine some group's language, fits better with the underlying data that the LLM was trained on as opposed to others, and so the updates, might not be different. The update, the degree to which the model updates might be different for those different groups. And so I'm not sure how you get around that. I'm sure some smart CS people are going to maybe figure this out at some point, and that would be great. For me, for a lot of my research, then I'm sticking to the word tibet that I can trade on my own corpus, which leaves me light years behind all the cool papers that are computational social science now. But I'm really dedicated to this constructability to the point it's going to be a ship that I'm going to probably die on. Another thing that I would add in terms of the limitations is there's a question of reproducibility, right, in the social sciences, and I think psychology has come to terms with this, a bit more than for instance, my home discipline of sociology has. But for instance, if you're using ChatGPT, this is owned by OpenAI, and they tell everybody we're constantly updating this thing, right? When people interact with ChatGPT, it is no longer the same thing that it was yesterday. And so you're kind of giving up on reproducibility altogether, which is a very scary thought. And there's no real way then, to justify the decisions that you're making in the research process. For instance, if you're using it to code some set of documents, et cetera. I do think there is, the access stuff is very scary. Thinking about when this becomes a paid model, is it something that's going to anti-democratize science? Now this is a tool that journals really value, for instance, and it's like levels up your publication by 2 or 3 tiers, but only those in like elite universities have the library subscriptions to access to these models. Like, it's very scary. Yeah.
Especially when they become authors on the paper.
Become authors on the paper. Yeah.
Can I add something to all this? I know we've gotten to the point of like we're all terrified, we're all scared, but I want to give an example of when they did use a big model on a small data set and it actually turned out pretty cool. Because I think because of these big models have like all these preconceived notions, we're just like, we have to be more clever when we have a small data set. So an example of this is Dallas Carr had a paper on immigration across like congressional speeches. And that's a small data set in the scope of like how much data you could actually have. And he was interested in how dehumanized immigrants were in this data set. And he used like Roberta or some big pre-trained model. And the thing is that these pre-trained models know a lot about what dehumanized like entities might be like. Like they know how animals are talked about, they know how robots are talked about. And so what he did is he masked out all the words for immigrants in these sentences and looked at what Roberta was predicting as substitutes. And I think that's such a good way of using like big models that know a bunch of things that you might not want them to like, you just know, like maybe we could call it common sense reasoning, but it's like, I don't want to use that. I know that term is very overloaded. There's a lot of burden to that term, but there's a lot of like knowledge about how the world works that you could kind of leverage for these like very small domains. So I know we're scared, but I also want to like just give that example.
May I add something? And quite frankly, all that you guys have described has been done before when survey data was used, right? Because unless you were able to do panel surveys, which will give you continuity, you only had one point in time. And again, it was expensive, not very reproducible. So you were basing whatever came next on very broad generalization. And again, the universities that were able to do the big panel surveys were very few. So to a certain extent, it's an evolution of what has already been seen. And to build on the point that Lucy made, we all lived, with what was done before. So there is really no reason at this point, to a certain extent, to be careful, but also, to use the technique and the models to see if you can extract even more. Just like
Okay, I just wanted to add to your point. I think this is a great example of one study where this can bring a lot of value. And I think when we think about it and contrast benefits and disadvantages, it's important to keep in mind sort of which part in the scientific pipeline are we trying to like put this model in, and like where do we want to help humans. So that's one example of almost a bit like exploratory analysis. It's like we mask it and then we want to discover which other terms somehow correlate, which is very, very, very useful. And I think that it can be very helpful to just use like precise terminology regarding that, because like now this example that you gave is very different from the example from the beginning where we talked about, for example, using GPT for qualitative coding, right? Because there it's a lot more scary and people react differently when you propose to completely remove the human who is at the beginning of the scientific process, follows an established methodology, for example, grounded theory, and follows like a specific set of things, to now just say, let's just let a model come up with like topics and annotate them, and that this will be our qualitative coding. So that's just one point that I wanted to make, that it would be helpful if we think, like where exactly are we trying to help use this thing.
So I definitely agree with that point, thinking of where it comes in. But like with this card paper, for instance, like it's longitudinal over time, like 100-something years, right, of like congressional discourse. I guess my concern is that the preconceived notions that, for instance, Bert brings in is going to be more representative of the thoughts and feelings of people in 2015 or whatever, as opposed to like 1930. And so if that's systematic and is in a way that basically biases his estimates of dehumanization over time, then like the conclusions that he draws might be, might not be valid. And we just, the thing about like surveys, for instance, is like there were people for like 100 years who like spent their lives trying to figure out how do we do a survey, you know, and like what are all the kinds of biases that we can imagine, you know, a survey having, and we think about, you know, statistics, random samples from populations, which surveys are not, but at least we have the model of like where things can go wrong. And I worry that like we never got the model down for word to vec, and now we've like moved on generations beyond that to the point where we don't really know like, can we test whether BERT, you know, is, you know, better measuring, you know, the ideas of people from the 1930s than from 2015? Maybe you could do something like just comparing how well it can predict language in general at those different time points, and maybe that would you know, satisfy our viewers. But typically, I don't even see like that kind of bar being met.
Yeah, I think definitely validation it's something that I think is always kind of funny. Is like I spend so much time building models, but then I spend so much time validating and evaluating them with humans, and I'm like, I could have just asked the humans. I guess I can't ask the humans to annotate billions of rows of data, but there's this thing where it's like I'm kind of like I have to build the model, but then I also have to validate it. And I guess validation kind of decreases. Like you could do some sort of validation where you like give some sentences from like the 1930s, see what substitutes BERT is predicting, and then give it to humans and be like, do you think that like this is a very dehumanizing context for this word? And you can like validate through that. But it does seem kind of interesting how like so much of AI is just like human evaluation surveys, like very like old school kind of like work. Yeah.
So you painted a fairly bleak picture. I guess a couple of follow-up questions come to mind, and one of them is that a lot of the points that you made is that the biases that you brought up tend to be in like the data, its distribution, its, you know, perhaps lack of multilinguality, and there weren't any objections that were really raised to the structure of the model itself. Are we just very happy with transformers now? And the other follow-up, so jump on either of these if you want, is yes, it's good to be aware of these biases and to keep them in mind, right? But what is the next step then? What does action look like? What are some things that work in order to mitigate some of these biases?
So start with this.
With
respect to are we happy with the structure of these models, I think NLP has sort of converged on like transformers being kind of like a local optimum, and then a lot of work in like the architecture space is now making like iterative adjustments to transformers, either make them more efficient, help them handle longer context, and so on and so forth. There are some very novel architectures, like period. There's something called S4, which uses like state spaces, which is from Chris Ray's group at Stanford. There's some also from Chris Ray's group trying to explore the use of large convolutions for handling very, very long sequences. Because one big limitation of these models is their inability to handle things over like 4,000 tokens, and actually for most publicly available models, it's actually much smaller than that. It's like 512 tokens, right? And so if you want to, or if you're interested in exploring long distance connections between pieces of text, then this is a major limitation of these models, something that may be resolved with scale, but I think will require some more fundamental rethinking of architectures. And with respect to how can we sort of mitigate these problems and make adjustments according to the biases we observe, I think you can divide it into two schools of thought. The first school is essentially that we should be very careful about what we put into these models, basically take a very cautious approach and start from the top down. Whereas the second school of thought basically says, okay, let's just have as many starting points as possible out there, and then do post hoc editing. And this can be just filtering what the model generates, which is the easiest thing to do. It can be explicitly editing the model, either editing the representations, like in vector space, or there's some more recent work on editing the model parameters themselves to update certain subsets of knowledge. And so I think these two schools of thought, like there's personnel-wise, there's not a lot of overlap between them, and at this point it's hard to say which one will prevail. But I think broadly in the NLP community, people are more focused on more fundamental problems, like optimizing for metrics, like perplexity or whatever, and this kind of thing sort of falls by the wayside most of the time, unfortunately.
Yeah, I think that, especially in computational social science community, I don't think there is a reason to believe we're totalitarianistic. There are some also actionable things that could be done, and one thing that comes to mind is related to the concept of construct validity that was mentioned before, and what does that mean? But I think that computational social science can also draw inspiration from other fields that found some ways to deal with that, at least to a limited extent. So for example, in epidemiology or digital epidemiology, when they work with digital data sets, they do try to establish the connection between real behaviors and what you see online. So for example, just to give some examples, if they base studies on mobility data, then they would have a section in the paper where they try to show that how people move around in space actually correlates with whether people get COVID in real life, and then use that as a proxy, or whether what people post online actually correlates with what people eat. So that would be one way to establish construct validity in that specific case related to digital epidemiology. So yeah, that made me wonder whether if the goal in computational social science is, for example, to use NLP to infer people's attitudes, or attitudes through language, in the mission paper, could we do more to establish the construct validity, or at least try to do some kind of evaluation where that is the goal. But perhaps that is what you were hinting at also when you were talking about human validation.
Yeah. I can also throw another example of what I've been kind of thinking lately, where it's these models have preconceived notions, then how do I mean, you wanted to talk about structure, but just to build out what you said is that I have this problem where I'm trying to measure different attributes of people in text, but the problem is that some people's names are very rare, and so if you give them pre-trained models those names and those sentences, they might perform worse. So what I'm going to do is I'm actually going to validate where I separate out the names that are rare and the names that are more common, or even perturb the names from common to rare names, and then just see how the performance drops. So I'll use the validation as a way of adding either pointing out a problem that I need to fix, or adding some reassurance that my results are robust. And so I'm scared, but I'm not that scared, because I'm I have labeled data, I can do this type of validation and do this type of perturbing experiment. In terms of structure, so I don't think that much about structure. I do complain about structure, but I don't do much about it, and I'm so applied. And so I'm always in the mode of there's this newest, latest model, I'm going to use it in my work, because then if I don't, then you're just going to be why didn't you try this newest, latest model that everyone else is using? And so then I just use it, but I don't actually do any of that architecture improving work. I might do little tweaks here and there, or go into the model and get certain things from the model itself, but I'm not going to come out with S4 or something like that. So I just look for people who come out with these models, and then I try to use them, and then if it doesn't, for example, I tried to use Longformer, it was taking so long in my text, and I was I don't have time for this, I need to because I'm a computational social science, I have to worry about collecting my data, and then validating my data, and doing all these other steps, coming up with social scientific questions. I'm I'm not gonna make Longformer better today, I'm just gonna do with what I can, Yes.
So I want to add to the construct validity point. And if you go back to the psychometrics kind of literature that really thought a lot about survey data, for instance, there were different kinds of validity, right? So one was face validity, the question I'm asking seems to correspond on its face to the construct of interest. I think computational social science methods right now typically get a check for that, right? Typically, it seems pretty face valid that the measure we're using tries to correspond to the construct. Then there's convergent validity, which is typically the kind of validation we do. I have some other measure of the construct of interest here, my theoretical independent variable, and it correlates with the measure that I want to use in my theoretical test. But the one that drives me nuts that people don't really seem to think about too often is discriminant validity, or discriminant validity, which is basically, you can imagine other constructs that are closely related to the theoretical construct I'm trying to capture, but my measure doesn't correlate with those, more than I would expect if it was capturing the true underlying construct. And I think this is something, for instance, you want to measure, trust in society, you want to make sure you're not just capturing happiness or something like that. And so, I don't see a lot of those tests in the computational social science kind of works. And I think, that's really key because basically there is this underlying concern with a lot of computational social science stuff that, when I'm measuring, the positivity or negativity of names, for instance, in a corpus, I'm really just measuring, the frequency of those names or something. And I think, we need to think a lot more about establishing discriminant validity, and we can take a page from survey researchers on how to do that. And in terms of the kinds of research that I think would contribute to helping recognize and fix these kinds of biases, I think there's at least 3 kinds of papers that can do this, or kinds of research projects that could do this. The first is, showing an analysis, that is showing that there is some kind of bias in an existing analysis. And so, for instance, I have a paper where, we measure basically at the MSA level, so at different, geographic regions of the United States, racial bias in Twitter language. And we show that correlates with all different kinds of, survey and experimental-based measures of racial animus. And, we did that analysis and we had 5 or 6 significant results. We're like, oh my gosh, we've got a PNAS paper here, maybe something, even more exciting than that. And then, we're doing some robustness analyses. And I'm like, well, I've seen some stuff about this word frequency bias thing. Maybe I should just check that. And so, measure, then the frequency of these different names that we're using, in this analysis to measure, linguistic bias. And that explains the entire association. So basically there was this underlying bias in the word embedding models we were using where they treat more frequent words as more positive and less frequent words as more negative. And that, so then we end up publishing a paper that's watch out when you're using word embeddings because this can really throw off your analysis. We do, a lot of explaining on what that means, et cetera. But I think that kind of paper, is somewhat useful, although it's really kind of piecemeal. Another version of a paper is to, for instance, look at, how do these word embeddings, how do these different language models act in hypothetical situations? And so, for instance, I've seen now a couple papers that do this kind of random shuffling of language. So if we have randomly shuffled language, we train a word embedding model on that shuffled language. What does it still learn? And I think that work has pretty conclusively shown that there is this really strong frequency bias in, for instance, word2vec and other language models. And I think that's probably much more valuable. And I hope there's more research done like that. It's kind of like gaining empirical research. It's doing empirical research on these language models, which is kind of interesting, but it's kind of important if we do want to use these models for social science. And the other one is using different kinds of models to answer the same question in the same data set and then compare them, and then see where the models disagree. And I think that could be really generative and would give you a lot better understanding of your question with the particular data you have. So you have a word embedding based way to do, to answer your question, but what if you also had a topic model based way in a word count, a word frequency kind of way to answer the same question? If all those three things agree, we can be more confident, and where the models disagree, we could learn something about how these models work.
We've said a lot of different types of validity in this conversation. I just want to mention there's this paper called Social Data Biases, and it has a longer title. It's by Alexandra and some other people, but it's a paper that I like to assign people to read, partially because there's so many different definitions in it, and it is so comprehensive. Every single type of ways your data could be wrong or not what you want based on whatever assumptions you're making. Alexandra just details it. She talks about design, the effects of a platform design on the data and how that might cause data biases. She talks about all the different types of validity, and so I think it's just a great if I were to teach a class, that would be the first paper I assign, because I'd be watch out for this when you're working on your final projects or picking data sets. Yes.
I think it's very helpful to think about a framework that can put together all these kinds of biases and different issues to validity and different ways to think about construct validity. Another paper that comes to mind is the total error framework for online traces by Ethayarajh, where they try to translate the framework of survey error into digital data. And then I think that's cool because we are trying to use something that already exists and then use similar terminology, which also helps facilitate discussions between fields, which is something very useful. And then I think also in this discussion it's important to think that a field is group of people who do science who come from like different, especially for computational social science, who come from different backgrounds, and I think that partially explains why we're not so much focused on these kinds of issues that are discussed so far, but more on generalization and like domain shift, because that's something that NLP is and machine learning is pretty much focused on. So yes, I'm happy that you mentioned the framework, and I think moving forward it's important to think in that way.
So, I mean, Kristina, you bring up a good point about like what a field is. That it's people working in similar ways but potentially with different backgrounds. And computational social science is fun because the backgrounds are often radically different. So, when you are trying to bridge this divide between people with different backgrounds working in computational social science, what sort of things have you found deserve to be clarified for people who come from one camp or the other, if you're trying to make sure that the collaboration goes smoothly? What sort of things have you seen as either like opportunities or pitfalls?
Do we want to keep changing up who starts?
We can put it on shuffle if we want.
Anyone?
I'll talk first. I'm very talkative. So I did a podcast about like collaborations because I really wanted people to like fight on the I didn't want them to fight on the podcast, but I wanted them to like really talk to each other, be like, how did our collaboration go? We come from different disciplines. What were the things that we juggle a lot? And something that came up a lot was respect, like mutual respect of each other's disciplines. And another thing that I think is really important for making these collaborations good is Dan Jarowski told me this, where he was like, we were about to start our project on textbooks and we were going to work with people in education. And he said, don't parachute into their field and like, just start like wrecking havoc or whatever that. Because I was a computer science, I still am a computer scientist, but I was like in a computer science department talking to someone in education. And I think a lot of computer scientists have this like techno-solutionism mindset where they're like, we're gonna parachute in, we're gonna disrupt, we're gonna build things, we're gonna move fast, break everything. And it's just like, no. Mutual respect is very important. I think patience is also really important, at least for me, because I am usually the person implementing things. And often the people who are like more social science leaning, they might be thinking about the questions and they're like, where are the results from the model? We need those results so we can start like seeing if our questions are actually answered. And it's like, to get to the result part, I need to like get the data set, I need to build the model, I need to validate the model, get the data for the validation. And so I think patience is really important, and like understanding that like there's a lot of intricacies in each other's like thinking and like the things that the tasks that we're doing, and we might not understand each other's tasks, but we need to have that patience. I think structurally, what to make these collaborations actually like more common in the future, what needs to happen are like funding issues, like the fact that like in STEM, usually we have more funding than people in the social sciences, and what kinds of power differentials happen because of that funding difference, right? And what kinds of things are we actually allowed to do because of that lack of funding in one area or more funding in another? Also, it's just like even at the undergrad level, I think there's these barriers to people taking classes in each other's disciplines. Like at Stanford, I feel like there was not this problem as much, like you could just cross and roll across departments, but at Berkeley, they have a lot of gatekeeping. And so I think like just early in the education pipeline, there's these like things that are not going to allow these collaborations to happen. And then later on, there's also like big like NSF level types of gatekeeping and barriers.
I can go next. So yeah, I agree with all of those points. Something that also comes to mind, like specifically, so as a computational person trying to collaborate with social scientists, is just a completely different way sometimes of even approaching a project or approaching science. So from computational side, people are often like completely theory-free, so you just have a data set and then sometimes maybe not even a clear, but people would criticize as like opportunistic approach to research. So like we got a really cool data set, no one's looked at this before, so exciting, guys, this is so exciting. Like let's explore it, let's analyze it, and starting from data, then generating questions, and or if like building models, even like the big models, they're completely like theory-free, right? It's just building things on a large data set, but that's not how it's traditionally done in social sciences, where there is a theory, you form hypotheses based on theory. There are also other ways to do it, but I think that usually there is a theory in mind, so that like in a collaboration, sometimes it would happen that I propose like, let's try to like model this and predict this and then see what is important and then learn something about the phenomenon, but then like the social scientists would ask, what is your theory? What theory are you testing? And I think to have a successful collaboration, it's important like from the beginning to be on the same page on like what are we trying to do, why are we doing this, how are we going to approach this, which might sometimes be easy to overlook when you are like, in the heat of the moment of starting a new project. And so that's one sort of theory or theory-less how to approach it. And then another one is also like what exactly is our goal? Because I feel that in NLP, especially like social NLP and NLP computational social sciences, it's very geared towards predicting and doing predictive modeling, whereas the norms in more social part of computational social science are explanatory. So with models, we look at coefficients, we want to explain something. We don't care about generalizing to test set, generalizing to other populations, being very accurate. And that's quite a big cultural difference in approaching science. And so then also when starting projects, sort of being clear about the types of methodologies that would be used and the goals, but being clear about that with collaborators is something that I found useful.
Yeah, I think there can sometimes be a lexical gap when talking to people from other fields. For example, I think it's great that Arya asked us to like distinguish between the two types of coding, for example, because it's a very simple example of how things, even innocuous words, can be very different across fields. And oftentimes, especially in computer science, we're used to talking to each other like in very technical terms. And so when we talk to people outside our discipline, oftentimes we don't think that, we assume that they have the same like prior over the field that we do, and oftentimes that's not the case. And it can be true in the other direction as well, where sometimes you're talking to an economist and they talk in a particular way and you're not quite sure what that means. And I'd also like to echo Kristina's point about the differences in the goals of projects. So in NLP, we often use like very large, like over-parameterized models, and it doesn't really matter if it overfits because we can evaluate on like a validation set and then make sure that doesn't happen. So we just want the models to be as big as possible. Whereas in other fields like in econometrics or even in like quantitative legal analysis, people really want to use like simple linear models that are super interpretable because the goal is to ultimately take what you've learned from this empirical analysis, match it to some theory, and then give like a much more satisfying theoretically grounded explanation. And so I think the goals of what you want to do in a project are quite different, and this can sometimes like lead to some conflict, especially if you haven't decided on the venue in which you want to publish something, because if it's going to be intended for a legal journal or a SOC side venue, it's going to be very different from like a pure NLP venue.
Yeah.
I'm going to give a quick example. I once wrote a paper where I had to explain what a token is because, like, what is a token? And I used an example about a cat. I was like, the cat sat on the mat. There are like 5 tokens in this. Actually, I don't know how many tokens there are. 6 because there's a period or something. And I was like, there's this many tokens in it. And then the reviewer was like, I don't know how the cat token relates to the tokens in your data set. Like, are there cats? Like, where are the cats coming from? And I was just like, I wanted to use a simplistic example. And then they were just like very upset. Yeah, anyways.
Yeah, I think, so coming from the social science side, like, I think it's important to recognize, like, social scientists, like, we're paid to test the theories, right? Like, and we take a whole class in sociology departments, like 1 to 3 classes on theory, specifically, like reading people from like 100 years ago and the theories they developed. And then we take a class, like at Stanford and a lot of other places, we take a whole class on meta theory. You're like, what is meta theory? It's like how to do theorizing and how to think about how measurement relates to theory. And so that's like the most important thing for most social scientists anyways. I think that can be like kind of frustrating. Like, and now like having taken computer science classes, it's like, you know, if your goal is to increase this number, right, the degree to which you can predict on a, you know, test set, like that is a super powerful thing because everybody can work towards the same task and you can have this really cumulative knowledge. It can be really fast paced and you can, you know, make amazing large language models that do really, really well. But like, I think, you know, it doesn't automatically translate over to social science, so there's a lot of like work to do there, and a huge part of it, I think, is like learning each other's vocabularies, and that's a lot of hard work, and I'm sorry for failing at that so early on in our roundtable. But I do think also like on the social science side though, there's like a lot of blame to be placed too, because you know, we did a lot of this, like a lot of the people who developed this meta theory did this in a time before, you know, machine learning was like this, you know, thing that any old researcher, you know, could like use. And so the meta theory is actually not set up very well to deal with, you know, the use of machine learning in social science. And so I think there's kind of this aversion from social scientists because they think if you're ever doing prediction, you're not doing explanation. I actually don't think that's right. I think we just have to kind of change a little bit how we think about the meta theory. And I think it's totally accommodating actually to the use of these methods in a large swath of, you know, tests that would be very scientifically valuable. So I think there's kind of, a lot of translation work and going between those two kinds, as other people have mentioned. But then I think also social scientists need to kind of update how they think about testing theories and how they think about, you know, deductive social science in general.
I have one very quick follow-up question. So I think in the examples you gave before, it seemed like the big models can help test like existing theories and be helpful to social scientists. But do you think that there is a way, or do you know any examples where these big models and big data can actually help us like develop new theories?
Oh yeah, I think they're super helpful for inductive social science. Yeah. So So vocabulary.
I would.
Sorry. So in meta theory class, you know, we'll learn that there's you know, we typically think about at least two different kind of modes of doing social science research, though people will say there's at least, you know, 3 or 4, but there are two primary ones. You'll see inductive, which is the idea, you know, we start with the data and we're kind of interested in a phenomenon, right? And so we'll start looking around the data, and for instance, this is very common if we're like interviewing people who are like part of an interesting group or something, and the idea is that we'll generate a theory, we'll induce theory from the data. And then the idea is that then that has now produced new theory that can be tested by others. And in the deductive social sciences, we start with a theory. It's like, well, this theory would predict this about the world. And so then we'll derive, you know, some test of that, you know, theory. We'll derive a hypothesis from it that will, you know, say, if we measured this about the world and this about the world, those two things should be correlated, or they should be negatively correlated, or there should be some pattern that we can predict ahead of time. So, you know, like, E equals mc squared, that is a very specific theory that you could go out and measure, you know, m, and we already know what c is, but you can take those and you should be able to predict what e is very precisely. And so then you could go and deductively test whether that's true or not. So yeah, that was the inductive-deductive divide. I don't remember why.
I guess my question
You were explaining so that people would understand,
Right,
yes.
I was asking how we can do inductive, so how can we use theories.
Yeah, I think. Some of the work that actually, I guess with large language models, I don't think I've seen examples of that I can think of off the top of my head. But like, for instance, there's this researcher at Stanford, Giovanna. He's in the psych department. He's also affiliated with HAI. But he does a lot of, you know, exploratory or inductive language analysis, where, for instance, he'll take, you know, a set of, you know, Facebook posts from a bunch of individuals who we have, you know, data on their gender identity, their age, and their personality. And then we can just do a bunch of correlations between word frequencies and those characteristics. And then we can inductively identify the kind of words that correlate with these different characteristics. And then we can present it in a nice word cloud. And then we as humans can look at that word cloud and make it, you know, and we can interpret that and come up with some kind of theory out of it.
I find that very exciting and very useful because more so than other applications of large models, because I feel that here the preconceived notions that were mentioned before perhaps matter less because we use them in unsupervised way to derive topics, but then ultimately like human would look at those topics, look at those examples, and start to build a theory from that. So perhaps it would be less likely to be shifted in weird directions by preconceived notions.
Earlier you mentioned prediction versus explanation, and something that I've I've been wanting to read. I want someone to write this paper. I was gonna write it, but I didn't have time, which was like, there's all this work on like in black box NLP, on like interpreting language models and like figuring out what's going on inside of them. And there's always like, there's people in computational social science who love logistic regression and love random forest because you can see the feature importances for things. And so I'm wondering if there could be a paper from hopefully someone in the black box NLP community where they write for a non-NLP audience and they say, what can you trust from tools like Line, from all these other tools? Like maybe you can't trust anything, but maybe that should be the paper. Is like if you're going to do it, here are the like things that you should be cautious about. And I want it to be written for a social scientific audience, so that way there is some like, okay, maybe you are not going to use like just logistic regression and random forest, but you can also look at like some like more cutting edge new stuff that's coming out. And I've been waiting for this paper. Someone needs to write it. Like, yeah.
So I'm organizing Black Box this year. I can nudge people in that direction. Sure. I think maybe one of the pushbacks that we might get there is like, you already sort of have these problems, right? Even with logistic regression, there is issues of like multiple linearity. When can you trust it, right? So then you're now asking to like nudge people toward like when you can trust these like salience-based or other measures in the incredibly over-parameterized models that we were talking about. And this gets to I guess just the questions that we that you were answering earlier. So if you have these things that are just massive and like hard to trust, how do you convey this? How do you bridge this divide in a way that like is approachable but is also informative when you don't have, you know, as Austin was saying, really the theory built for some of these like hard components, and now we're generations ahead.
I don't know, I just feel like even just saying that could be helpful, you know, because I think there's a lot of people who are like outside of that community and they're just even thinking they're like, I know that this community exists, I'm wondering what they're up to. They sound like they're just all screaming together, possibly in a black box together, but like I'm just like distilling some of the main points and then being like, this is where we're at and this is where how social scientists should look at this work and figure out for themselves how much they want to actually dive into it further. There are some good survey papers, and I feel like we kind of need a survey paper every year because of how fast it's moving, but just like something that's written in a way for someone who's not an NLP, when they're like, oh, I've used logistic regression, I kind of trust it, and I've used random forest, I kind of trust the feature importances. What's the story for these newer things? And I don't think there's been that bridging yet.
I agree, and I also think that no method is perfect, so at least showing in some standard data sets that if you use logistic regression or if you use a neural model with some way to explain things with saliency, you get comparable things that would be convincing to folks that, okay, I might try to use this more advanced things that has all these advantages and then all these disadvantages.
That's why I'm a big fan of also like initiatives like BERT for Humanities, where they have like these tutorials and they're like not built for people in computer science. Just like that translational work should be valued more if we want more computational social science to happen.
So a question that this sort of naturally leads into is that, you know, you're all postdocs or PhD students, you're, you know, young.
I feel old and sad.
Yeah. Yeah, I mean, we were all, you know, 20 years younger when we started the PhDs, right? But there are colleagues that you have that maybe have different attitudes, that, you know, they were, you know, starting their training, even finishing their training before this deluge of data and this availability of massive compute. So what sort of differences in the approaches, in the attitudes, and in the outlooks do you see between yourselves and colleagues with maybe that difference in their training?
I mean, I'd say like on the social science side, I feel like the kind of like standard for like my advisor's kind of generation was when you're doing an analysis, you make kind of ridiculous assumptions about the data, like about the distributions that it comes from, et cetera, and the kinds of error that are present. But then you get these like nice theoretical guarantees, like about like, you know, this is, you know, so there's like this acronym for if you use like a basic ordinary least squares linear model, like it's blue, it's the best linear unbiased estimator, and you have to like learn that in your methods classes, you have to know all the assumptions that go into that. Even though these assumptions are almost like never true of the data. And I think we're coming to learn that, like, you know, with all the added computation and all the data we have, you know, we don't need to be making these crazy assumptions, at least as much. We can definitely reduce the laundry list of crazy assumptions we're applying to the data, and we can still get just as good, inference on things. And I think you see that in all kinds of domains. So for instance, like the one way, social scientists would think of as a way to cluster data, we're using like latent class analysis as this method that people use. And if you start to look at the assumptions, you're like, this is probably almost never true of any survey data I've ever measured in my entire life. But then, you can instead use something like k-means, which doesn't really make, as strong of assumptions about, say, the distribution of the data. But there's a lot of resistance to that, because but you don't have any theoretical guarantees, et cetera. Sorry.
You made the point about k-means not making very strong assumptions.
Oh, but you would say it does.
I mean, I would say it does.
Okay.
It has certain heteroscedasticity complaints,
Mm-hmm.
and you want that the clusters are reasonably
But
separated.
you have never been in a room with people, social science, discussing the very strong assumption. It's a much more heated, because sort of.
Yeah, I think it's in comparison, right? Like,
Yeah.
If you look at like latent class analysis, it's like, there are like all these assumptions about, independent of the factors that we're, analyzing, then there's no correlation between the other variables. And it's like, I don't even know how to think about whether that's true or not. It's so like abstract. But somebody wrote, did the proof of like, but if this is true and these 5 other assumptions are true, then you get like the best clusters, right? Exactly, huge if, right? But like, I think in the training it was like, but there are some theoretical guarantees, right? Like, if these things are true that are never true. And so I think, again, we're finding that like, even if there are problems, like empirically you can find about k-means, like it's not built on a theory that makes crazy assumptions about the data. And maybe k-means maybe it's a bad example. Maybe I don't know by clustering algorithms well enough, but.
The classic claim is that there is no free lunch, right?
No, but probably one in social science is that there are a little bit less strong assumptions. It's a little bit more relaxed nowadays in the way in which you go about data and hypotheses and how the two go together. And there is a little bit of, I have the data, I can always retrofit, right? You can do that. But 20 years ago, 30 years ago, you had to go a much more structured way. So that would be probably the change that has happened. So.
I tend to surround myself by people who are very encouraging of bringing theory into NLP and also using NLP in their domain applications. So I feel like the people that I talk to, I haven't talked to anyone who's has these old-setted, anti-whatever I'm doing. But what I do kind of face are maybe at a broader level, or the institution or the ACL itself level, which is things like in computer science we move fast, we should publish papers every year, we gotta hit these conference deadlines, and it just does not really, the norms against which I'm evaluated as a scientist do not fit well with some of the emerging things that I'm trying to bring in, like participatory design. If I wanna interact with real people, real students, real schools, I have to build the relationship with the school. If the school decides to not want to have a relationship with our research, months into our research, then I basically miss out on all the STAR ACL deadlines that year. And also, if I decide to do translational work and publish in non-ACL venues, it's not counted towards my resume if I'm going to go on the market as an NLP person or something, or even try to apply for internships. And so there's these other things that are kind of baked in of where are you? Are you one of us? Are you on the borderline? You can't be on the borderline. You've got to choose a side almost. I remember when I came into the PhD, I was so optimistic because I was I'm going to be interdisciplinary. And then I realized that you do need a home discipline, because then when you're positioning yourself and you're collaborating, you have something that you're bringing that's depth. Yeah.
So would you say then that computational social science is not a discipline, a home in itself, in that there is this tension between backgrounds and you still have to align yourself? Is that what
That's what I'm thinking. That's what I'm thinking.
A big field would have its major conference or its major journal. That would be one way to think about it. What would it be for computational science?
Can I just add a quick thing that
I don't want to ask.
well, just because we're going in order, I don't just a quick thing though, the departments are key, right? Because they make the hiring decisions, right? So if I'm a computational social scientist, there are some, interdisciplinary places, that I can apply to, but mostly I'm applying to sociology, right? And so then I have a group of sociologists, right? And that's the center of the department, right? It's like we respect, the American Journal of Sociology, the American Sociological Review, and Social Forces. These are like top 3 sociology journals. And if you haven't published in those, like, what is this EMNLP you're publishing in? What is this ICWSM? These are conference proceedings. Why do so you? Yeah, so you have totally failed, is what you're saying over grad school, right? Like, and to have a group of people who are the decision makers about the future of your career, who like speak the same language, I think would be immensely helpful.
I think one of the few exceptions are maybe like information science programs, but like a lot of schools don't have them, so then you have to choose a side.
And it's a very US thing, so
Yeah.
it doesn't exist really.
Well, a lot of computational scientists for computational social science end up in the School of Communication. That's where, in a lot of different places. And so they don't belong to either group, because traditionally the School of Communication it's a space for everyone, but then again, you're not positioning according to any specific discipline. So
the message here is that, when Lucy makes it clear, she's going to endow a department of computational social science.
There is a data science institute at Notre Dame called the Lucy Institute or something. I had nothing to do with it, but I often think fondly of it, Like, if I was to enter this, yes, that would be the institute I would be favoring.
With respect to interacting with people from different generations, my experience has been like almost uniformly positive, I would say. Like mostly because like I'm squarely like an NLP person, and so in such scenarios, like I already have people that are interested in applying NLP to the domain in a particular way, so they're already very open-minded. Sometimes they've worked with NLP people in the past, and they sort of know high-level jargon in the field. And so, yeah, my experience has been like pretty positive overall. I think I encounter like some resistance when, we write something and we send it into a journal, and then you have people who are not familiar with these methods being like, oh, you see us people trying to come into our field kind of vibe. And that's been my only encounter with it, but like personal one-on-one interactions have all been really positive.
interesting.
So we like to wrap these up with one sort of summative discussion on what has been called a CV of failures. So Giovanna explains the background to this really well.
So this comes from actually an economist/sociologist that I think he is Swiss, and he teaches at Yale at the moment. And something that he did with one of his classes was to suggest to students that whatever you have in your CV resume is the one success that you put there, right? But there are a lot of failures. And it would be interesting to write a CV of failures to show how many times things have gone wrong before the success. And he did that, and he posted it on his website. And to his surprise, he said, that is the most downloaded piece of work on my website, no matter what else I've published. But it became something very interesting, and so a lot of places now use it as a standard. And the idea is to see what you have tried, and sometimes with the best intentions, and it didn't work, and maybe see why. From a lot of what you guys have already talked about, there was a lot of that came out in bits and pieces here and there, but it would be nice to see if you guys can relate to one or two particularly interesting failures that may have generated a lot of good stuff.
So it is his most downloaded piece of scholarship, which he notes as a meta-level failure.
Yeah, that's true. He says that, yes.
But yeah, so the big question is not only the failures that you've had in trying to work at this intersection of disciplines, but also what it's taught you about the field moving forward. I can start if everyone's shy.
Okay, I can start. I submitted a paper to an education journal last year. Got my reviews back. They were awful. They just did not like it. They were just like, you're not using the right right terms. Like I didn't know the right terms for saying certain things, and that immediately signaled me as not knowing what I was doing. And one of the comments I had gotten was they were like, "You should use Lucy et al. 2020 as a mentor text." And I was just like, "Who is this person? Who is this Lucy et al. 2020?" And it's of course it's my own paper, so I like put my old paper next to my new paper, and I realized I peaked in 2020. So I was like, but that was like a moment of like, partially, so my advisor told me it was partially like the reviewers were maybe not like the most, I got kind of unlucky, but also I think they made a lot of really great points about, I might have rushed a lot of the explaining of terms, explaining of why I'm using certain methods, just like that bridging between the disciplines, I was being a little bit like lackluster at, not as good at it as I was before. And so, but that was just like a really funny review, you know, where people talk about getting reviewers who say, oh, you should have cited so-and-so, and the person is yourself, and stuff like that. And so I basically got something that was just like, you were better in 2020. But they didn't know who I was, so.
The mistake was clearly that you didn't have your cat token example anymore, right?
Well, I did, actually that was the paper that had the cat token example. So I had to like, I reread my old paper and I was like, how did I explain tokens in that one? And I looked at my new one and I was like, I explained it in a very similar way. So, and I have tons of other failures too. I've written so many like fellowship applications, they all got rejected. I've applied to so many random things, got rejected. I think, yeah, my CV of failures is probably 20 times longer than my actual CV. So.
Yeah, I also think that like for every published paper, there is like at least one thing that was abandoned, or I'm not sure about the ratio, but there were many projects that at different stages of the pipeline got dropped or things didn't work out. And one of them was a collaboration with linguists, but not computational linguists from another university in Switzerland, where we wanted to understand linguistic accommodation through emojis, and in particular in the case of Switzerland, where it's multilingual, so we speak German and French and Italian, and then also some dialects. And then trying to understand how when we chat on WhatsApp, you might change your emojis to match mine, and then how this changes between different languages. But it just, there were so many challenges related to points that I mentioned before, where the data was small, so it was donations from people's like WhatsApp donations that was coordinated somehow. So the data was small, and the computational approaches trying to predict what would happen next just didn't work. It was really hard to predict anything. But then on the other side, not computational, it was also not clear, even from the beginning, like what would be the goals and how do we want to approach it. So that one made me think that it's like so important, straight from the beginning, to define like how are we going to approach this problem. Are there some theories that we want to test, or we want to analyze the data? What would even be sort of a success? And then even the questions such as where would we publish this, where would we submit, and sort of who gets what kind of benefit from having a paper in one of the venues. Those were some challenging conversations and lessons learned.
Yeah, I guess with respect to failures, they were quite a lot of them during, I guess, like when I was getting started in research, especially. I kind of jumped around a lot before I settled in NLP. So initially, like during undergrad, I was like in a software engineering lab, like sort of like domain-specific programming languages and whatnot. And so that was okay, not great. So I was like essentially given this large code base to try to basically disentangle some of this code, and like the comments were in Portuguese, because the guy doing it was Portuguese. And so, yeah, I felt like I was very lost at points of it, and just like the mentorship wasn't quite there. And so I feel like, you know, part of, I think, the reason why people drop out of like doing research, especially early in their career, is just a lack of good mentorship. Because, and I think that's like a pretty big difference between, you know, what I see at Stanford or even Berkeley versus like a state school, like I went to the University of Chicago for my undergrad, is that people here like get a lot like more thorough mentorship. in some ways, I'm glad that I had all of these failures early on because I feel like it made me a much more independent researcher. To the point where like I could come up with my own research ideas at some point, and I could try them out and write a paper, and then half the papers wouldn't be accepted. But I was like, all right, so this is a loss, but I will take it and I will move on. And now I feel like I'm at a point where I can generate ideas that will generally pan out, and which I can explain to a master's student and have them work on it with interest. And so I think it was looking back, I think it was great that I failed so extensively during that part of my life, but it was certainly not very fun in my life to do.
So I see we're running close on time, but I'm going to try to get into two. One's kind of just like a meta level kind of thing, where over my grad school career, I feel like I very much learned to think in terms of papers. And I guess maybe this is just general advice, maybe, but and I feel like that ultimately was a mistake. I would highly suggest just in general, as soon as you feel like you have bigger questions you're interested in, think about the kind of project you would work on in terms of these larger research questions you have, because papers get boring by the end of them. I don't know if you guys would agree with this, but I feel like pretty much by the time I'm sending a paper to the journal, that ultimately gets accepted in, I'm so tired of this paper. But the big questions can kind of help you keep going. So I feel like that was kind of a meta failure over my grad school career, was thinking too much in terms of papers and not thinking about larger overarching questions that spans, for instance, multiple papers. More specific failure, this paper finally got published this year. I was looking back on when we started. It's been 5 years since we started it. And it's it's not like the analyses are super complex or anything like that. But it was we just really could not figure out how to pitch this paper to social scientists. And I very much had, I was the first couple of years of grad school, and I was learning all these computational methods. I'm oh my gosh, there's so much here to give to social scientists. And so I wrote it very computational social science coming to save the day for you sociological social psychologists who haven't seen these methods. And it's still very much the harshest reviews I've ever gotten on a paper. My favorite one was I got one that says there's literally no sociology in this paper, which so that caused me a lot to reflect. And me and my co-author eventually we sat down and we're okay, we know there's also a theory here that we've been thinking about. We need to write that as that's what the insight is for this paper, and the methods are a nice way to get at that question in a unique way, which was always in there, but it wasn't the thing that we were focusing on in the framing. So I think we finally got it in to a journal. It was fifth journal we sent it to. We just had to get hit repeatedly over the head with these reviews, being this is not, and learning that this is not the successful way to frame this kind of transition work, or this kind of bridging work. And very much to a point that was made earlier of having respect for the different disciplines that you're trying to contribute to.
All right. Well, thank you everyone. This was really, really illuminating. So appreciate the time and looking forward to continuing the conversation.
Lunchtime.
I like it. It's closing music.
I don't know why.